So far, we've been looking at one transformation at a time, but it's possible for a function to have been transformed in more than one way. Let's look at this example together, and then I'll let you try one. Can you see what the basic function is here? Do you see that it's the square root of x? We have some basic ordered pairs for that. Why don't you write them down here? You can see I have a note here on the side. I say that when we apply one transformation at a time, we start with any reflections. We don't have any reflections here, and we don't have any compressions or stretches. Those usually involve multiplying by a negative number for our reflections, multiplying by a fraction or an integer for our stretches and compressions. So we don't have to worry about that. The second step after those reflections, compressions, and stretches doesn't really matter. I usually like to start with whatever is closest to x. So let's look at our second function as the f of x equals the square root of x plus 3. What should the new ordered pair look like? Are we changing x or are we changing y? The plus 3 is inside the function. It's right next to x. That means we're changing x and doing the opposite of plus 3. Y stays the same. Why don't you find the ordered pairs here? You should have found these values. Remember, we were keeping this y the same, so all of our y values stayed the same, only x changed. Now we want to change the entire function and include both transformations. So we're going to look at the f of x equals the square root of x plus 3, and then minus 2. So we've already looked at this change on x. We already know we have this x minus 3, and those values are going to stay exactly the way we found them in the second step. But now we've got that minus 2. We're changing y. Yes, y minus 2. So we look at our y values, 0 minus 2, 1 minus 2, and 2 minus 2. Here are the ordered pairs for our transformation. But you should already have a picture in your mind of what's happening. When we have that change on x, the x plus 3 under the square root sign, we know that this is a horizontal shift. In which direction? Left 3 units. And then what about the minus 2? It's vertical, down 2 units. So you know what the basic graph looks like. You've memorized that square root function. And now you know that we're going to shift it left 3 units and down 2 units. Why don't you graph those ordered pairs in the final column and see what your new graph looks like? This is what your graph should look like. Remember, the first basic function started at 0, 0. We shifted it left 3 units and down 2 units. Find the domain and range for this function. When I look on my graph, I see that the lowest value on x is at -3. It's included on the graph, and then towards positive infinity. When I look at the range, I see that the lowest value is at -2, and then up again towards positive infinity. Remember this graph, the reciprocal function has 2 key points and 2 asymptotes. see if you can do the transformations. We'll start with the f of x as 1 over x. And then we'll apply this change closest to x. And then you'll do the final transformation. See if you can fill in each of these columns. So you had your basic function, everything you've memorized there. Because we have a -2 next to x, we know that x is changing, and we're going to add 2 to each of the x values. Here are the ordered pairs for the entire transformation. We had a +3 outside of the function, so now we were adding 3 to our y coordinates, which meant we changed each of these y's, including our asymptote. Graph this function now. This is what your final graph should look like. We've changed the horizontal asymptote to y equals 3, and we've changed the vertical asymptote to x equals 2. See if you can find the domain and range for this function. Pay attention to where the asymptotes have moved. Maybe look back to the original function that we graphed and look at that domain and range. Because we have a vertical asymptote at x equals 2, we see that that is our non-permissible value. So our interval is from -infinity to 2 and 2 to infinity. And for our range, we have a horizontal asymptote at y equals 3. So the range is from -infinity to 3 and then 3 to infinity. Make sure you practice these transformations. We're going to add even more in the next lecture.